Hello everyone. So in the last video we have already discussed about how to give the load definitions. So you can see here these are the definitions for the earthquake that we have given on the right hand side. Okay, and then in the load case details we have given it for earthquake in x direction, earthquake in x negative direction, that means both ways, then earthquake in z direction, both ways, then dead load we have given. Okay, and live load also we have given, and the live load we have taken as -2. Okay, because we have considered it as a residential building. For a commercial building it will be 4. Okay, so now if you remember your RCC design, there are various load combinations. Okay, so like here you can see there are various load combinations which are available, like 1.5 into dead load plus live load. Okay, then dead load plus wind load. Okay, 1.5 into dead load plus wind load, then 1.2 into dead load plus wind load plus live load, or dead load plus earthquake load plus live load. So let us give these combinations for the design. So let us first use this combination. Okay, so 1.5 dead load plus 1.5 live load. How will you give it? So you select this load case details, then you select add. Okay, then you will get define combinations. So this will be, let me write it down, uh, 1.5, this is the name. Okay, 1.5 into dl plus ll, this is just the name, 1.5 into dl plus ll. Now we have to give the accurate formula. So uh, select dl and write here 1.5, because 1.5 into dead load plus live load is equal to what? 1.5 dead load plus 1.5 live load. So now you have given 1.5 here, dead load you have selected, bring it here. Then again 1.5 it is selected here, then live load you select. Okay, and give it here. Okay, so now add, then close. So you can see here number 7. See, there are 7 loads till now. First one is number 1, nomenclature already given. Number 1, earthquake in x positive direction. Number 2, earthquake in x negative direction. Number 3, earthquake in z positive direction. Number 4, earthquake in z negative direction. Number 5, fifth load is dead load. Sixth load is live load. Seventh load is the load combination, 1.5 into dead load plus live load. Okay, so let me also give the other two combinations. Let us give this one. Okay, so 1.5, let me take 1.5 here. So 1.5 into dead load plus earthquake load. Let me do this. So again I will go back to load case details, select add, then see this is the 8th load. Okay, define combinations. So 1.5 into dead load plus, now there are so many earthquake loads, isn't it? So let me do it for all. So eq x positive, so at one point of time earthquake, one of the earthquake may occur, isn't it? Either this one, this one, this one, or this one. Okay, all the earthquakes will not be occurring in a place in all 4 directions. So at one point of time earthquake will occur in just one direction. So let me assume that at one point of time the earthquake is occurring in x positive direction. So that will be the name. So now dead load you select, then you select 1.5, type here, then bring it here. Then earthquake x positive, then the factor 1.5 is selected, bring it here, add. So you can see here 8 number load. 8 number load is this one. Dead load plus earthquake load in x positive direction. So let me also make the other load combinations for the earthquake loads in all the other directions. So load case details, load combinations. So let me give this name 1.5 into dead load plus EQ x negative direction. So in this case, dead load I will take factor 1.5, bring it here. Then factor is 1.5 already, EQ x negative, bring it here, add, close. So this is the ninth load. Okay, then again let me go back, define combinations. So it will be 1.5 into DL plus EQ Z positive direction. So DL 1.5, bring it here. Then EQ Z positive 1.5 is already there, bring it here. So add, close. So last one is x 1.5 into dead load plus earthquake x negative z negative direction. Okay, so let me do it. Define combinations. So 1.5 into dead load plus EQ Z negative direction. So dead load I am taking 1.5 here, it will go here, then EQ Z negative, then it is 1.5 here, add, close. So all these we have given. So for there, how many load combinations till now? 1, 2, 3, 4, 5 load combinations. So let me give another load combination, the last one, 1.2 into dead load plus live load plus earthquake load. Okay, so now again I'll go here, I'll add, define combinations. So 1.5 into DL plus LL plus, so here also it will be 1.2 plus earthquake. So earthquake may be anyone, so it can be EQ x positive, EQ x negative, EQ z positive, EQ z negative. So at one point of time we can select earthquake in one direction. So EQ, suppose x positive. So here the factor will be 1.2 dead load, 1.2 factor plus live load, then EQ x positive here. So add, close. So this is done. Okay, then for the others also I will be doing. So just notice it carefully. Load case details, add, define combinations, 1.2 into DL plus LL plus EQ x negative 1.2 dl plus ll plus EQ x negative at close. Okay, and then for the remaining two earthquakes, load case details add defined combinations 1.2 into dl plus ll plus EQZ positive. So 1.2 I will write dl ll EQ Z positive, add, close. Then last one, load case details, add, define combinations 1.2 into DL plus LL plus EQ Z negative. So 1.2 DL LL EQ Z negative, add, close. So after this, all these loads are given, like first number one earthquake, two earthquake, third earthquake, fourth earthquake, fifth dead load, sixth live load, and from seventh load onwards it is the load combinations, dead load plus live load, dead load plus earthquake load in all four directions. Okay, and then this combination. So we have done. Now we will be going to the design. Okay, so we have given the loads, everything. Now we just have to design. So let us go to the design tab. Okay, then when you go to the design tab, you will, if you notice on the right hand side, there is a thing written AISC 36005. So you have to select it for your design. So what is the design that we are doing? It is for IS 456 reinforced concrete. Okay, so when you go to the design tab, you have to first select concrete on the left. If you are noticing this cursor of mine, this concrete you have to select. Then current code, you this on the right hand side, you see somewhere you will get IS 456, this one. Okay, so it is done. So IS 456 we have selected. Now define parameters. What are the parameters that we need to define? First, let us define the grade of concrete. Okay, so for that we need to select FC. Okay, so for that we need to select FC, and if it is M20 grade of concrete, then it will be 20 Newton per mm square. That means 20,000 kilonewton per meter square. Okay, so if we take M20 concrete, we will write 20,000, because Newton per mm square, 1 Newton per mm square will be equal to 1000 kilonewton per meter square. 1 Newton per mm square is equal to 1000 kilonewton per meter square. Okay, so 20 Newton per mm square for M20 grade of concrete, 20 Newton per mm square will become 20,000 kilonewton per meter square. So we'll add it. Okay, then you go to Fy main, that will be the main reinforcement. Okay, main reinforcement. So if I take Fe 415, then it will be 415 Newton per mm square yield strength. So for here the unit is kilonewton per meter square. So 415 Newton per mm square will become 415,000 kilonewton per meter square. So I will write this like 15000. Okay, then again you add it. Then uh, secondary reinforcement. Okay, that will be the shear reinforcement. Okay, so secondary reinforcement I will also give, suppose Fe415. So it will be 415 Newton per mm square. So 415,000 kilonewton per meter square. Add. So I have added it. Then ratio. Maximum percentage of reinforcement. Let us take it as 3. 3% maximum reinforcement we will give. Okay, that is the limit. Okay, of suppose the cross section area whatever is there, 3% of the cross sectional area will be allowed for reinforcement. Okay, so I'll add it. Okay, so generally these are the things that you need to know. So when you close it, you will see that here in this dialog box you see code Indian is given. So you can see FC 20,000, that is grade of concrete M20. Then FY main reinforcement 415,000 kilonewton per meter square. FY secondary reinforcement 415,000 kilonewton per meter square. And ratio I have given 3%. Okay, that means 3% of the cross sectional area of a beam or column will be taken for reinforcement. After we have decided the like the grade of concrete, the grade of steel, and the maximum reinforcement, let me give the commands. Okay, now there are some question marks on the left hand side of these assignments. So I will tell you why it is there. Okay, I will tell you, I'll let you know. But first of all, let us start. Let us complete the commands. Okay, let us complete the commands. So now you go to this tab which is called commands tab. So design beam. We need to design the beam, isn't it? So add design column. We need to design the column. So add. Now we have not drawn the slab element, so no need to do this. And takeoff. Takeoff means total volume of concrete and weight of steel reinforcement for beams, columns and elements. Okay, so those will be calculated. So let us edit, then close. Okay, so now if you look into this last tab, start concrete design. Okay, if you look into this last tab, you can see here all the things are given. This is what we have done. So FC, we have told the computer that we need to give a grade of M20, but we have already told the computer, but we have not assigned the grade M20 in the frame. So how will we assign it? So we select this FC is equal to 20,000 and you select the whole frame, because concrete will be throughout the whole frame. So we have selected this and we have selected this. Okay, then if I write assign to selected beams and plates, it is selected. Now if I assign it, then what will happen? The whole M20 grade will be assigned to the frame. Okay, so assign, yes, So the now the whole frame, the concrete is M20. Okay, then main reinforcement. So main reinforcement will also be provided throughout the whole like frame. So select this. Assign to selected beams plates. Assign, yes. Then secondary reinforcement for shear also we will be providing it throughout the whole frame. So I selected it, secondary reinforcement. Assign to selected beams. Assign. Then maximum ratio 3%. That will also be considered throughout the whole building. So I select the whole building, ratio 3%. Assign to selected beams. Assign, yes. Now design beam. Design beam, because beam design is different and column design is different. Here for beam we have to take the horizontal elements. So now select beams parallel to X and select beams parallel to Z. So these are the beams, isn't it? So design beam, and we have selected this, and assign to selected beams is already there. So I assign it. So these members will be designed according to beams. Okay. For design columns, we have to select the vertical beams. Okay. So select beams parallel to Y. Design column. So assign to selected beams is there. So assign, assign. So all this is done now. Indian code 456, grade M20, main reinforcement FE415, secondary reinforcement FE415, maximum ratio of reinforcement, maximum percentage reinforcement is 3%, beam design will be done, column design will be done, okay, and the volume of concrete and steel will be calculated, and then the concrete design will be ended. Okay, so I hope you have understood till this part. So after this, the final step that remains is about the design. Okay, and not the design, it's about the analysis. So you click on analysis, then we don't need print right now. Okay, so perform analysis, you don't need print. So add, then close. Okay, so you can see here on the right hand side this perform analysis has been added. Okay, then you can see start concrete design, code Indian, M20, 415, secondary reinforcement, 3% reinforcement, beam design, column design, concrete volume, steel volume, and concrete design. All these are being added now. Okay, so after that you select here in the top, and then you do the run analysis. Then the analysis will run. Okay, and it has run successfully. Okay, it has run successfully, and there are some zero errors you can see. Then it has been done completely well, and two warnings are there, but it's fine. Generally, sometimes when there are lots of errors, like it stops midway. Okay, now there are zero errors, so it is fine. You don't have to worry about the two warnings. Okay, so now we have to go to post processing mode. Okay, after the processing, that means. Okay, so done. uh, and we need to select all these load cases. Okay, because we will be analyzing it for all the loads, isn't it? earthquake in 4 directions, dead load, live load, and also for the combinations we will be analyzing the model. So now you click OK. So this is now the post processing mode. So what I will do is, in the next video I will discuss with you how to analyze the model after the processing is done. That means analyzing is done already. Okay, now after the analysis is done, how to check the values, how to check the loads, and how to see the designs and all, we will be discussing in the next video. Okay, so till now whatever I have discussed in this video, please write it down and submit it before 4:30 today for your attendance. So let's meet again in the next video in order to evaluate the model after the analysis is done. So today analysis is complete. We'll be evaluating it in the next video. Thank you.